Okay. Hey everyone, welcome to Smart Contracts 101, presented by BlockTEST. My name is Justin. I'm gonna be kicking off this presentation today. So here's the agenda for what we're gonna be talking about today during Smart Contracts 101. So first, I'm going to discuss, what is blockchain. I'm gonna go into some alternate versions of like storing information, and give you a high-level overview of blockchain. Then I'll hand it over to Hoyin, and he will tell us a little more about the details of blockchain technology. And finally, we'll go to Pratik, who will take us through the tools you'll need to build your first smart contract and show you an actual demo. So, what is blockchain? Really, it's just another way to store information. Like a database, you can store historical records and find those records later. So what makes it different than a database? Let's start by looking at the traditional form of a database. So here's Rob, and Rob is just a user on his local machine, and he wants to set up a database locally and store all of his information on his local machine. So there are some positives that come with a centralized database. It's very easy to set up. The data is all in one place, so it'll be accurate and consistent, and updates will be immediate. There are some drawbacks, though, such as there's a single point of failure, meaning if it gets hacked or something happens, there's really no going back. And you have a trust issue. If Rob sets it up and other people are trying to access the data that Rob set up, the other people need to trust Rob as a central authority to believe that the data is real and accurate and that he hasn't made any modifications to old records. So let's say Rob decides to start a business, and running a database only on his local computer is no longer enough to support his business needs. His computer, it simply can't handle all of the stress that all of these people are trying to access the data from. So Rob sets up a bunch of servers all around the world, which each contain different parts of Rob's data. So he has the data distributed bits and pieces all around the world. So some positives of this is that you no longer have to deal with a single point of failure. If one machine fails, the other machines can kind of step up and make sure that the database keeps running as normally, and it's easily scalable. So more data can be stored just by adding an additional machine. Some drawbacks, and for Rob's architecture, one of the drawbacks is data consistency. It's difficult to have the exact same data shared throughout all of the different databases. People could write queries to get data from Rob's database, and it might not be exactly the same in all locations. And you still have the issue of trust, where as an external user, you still have to trust Rob to ensure that all of the data is true and accurate. Rob can go back if he wanted to and maybe make changes to the data, although he probably wouldn't. This is something that he would be capable of doing. So how is a blockchain different? Rather than a single point of control where we had Rob before, with the data in the blockchain, the control is shared amongst all participants in the network. So here you see Rob, Mary, Jane, Billy, and some other people as well, and they're all helping to support this database, this blockchain, where every single person has a copy of the data. So some of the positives of blockchain is that you still don't have the single point of failure, and it's trustless. So you don't have a central authority that you need to trust in order for the system to work. It just works. So everyone has a copy of the data, and they don't need to really trust anyone else because everyone's working in the best interest of the blockchain. And the other key point about blockchain is that it's immutable. So no one can change what happened. If you record a transaction, let's say you pay Bill $10, and that record gets recorded in the database, there's no changing that. It will always say in the blockchain, Bill received $10. And, that can be good because, you can trust that the data in the blockchain is true and is the same data that was originally recorded. But you have to make sure that you're recording the data properly, because if you record the data incorrectly, since it's immutable, nobody can change it, and that will remain in the blockchain as that recording. Blockchain is not widely accepted yet. That is one of the cons right now, but as blockchain technology continues to expand, some of these cons could actually become positives with the blockchain network. And now I'll hand it over to Ho-Yin to go into a little more detail about what a block actually is. My section covered a high-level overview of blockchain, where decentralization and immutability make this technology unique. Now Ho-Yin will go into a little more of the details.
All right, so thank you, Justin. This is Ho-Yin speaking. We are going to introduce, blockchain is great, as we looked at the pros and cons before. So now we're going to a bit more of the technical detail and how, like what a block is and how blockchain actually works. So what a block really is a container of transactions with a few other things that's needed for a block, in a block for the blockchain to run. You can think of it as like a page in a physical ledger, where a different page would just be a different block would just be a different page in the ledger recording different transactions. So, well, one block is not useful, and let's see how we add blocks. And before going into that, let me introduce you what a hash function is. So what a hash function is basically a formula that converts an input to a unique output that has a fixed length on what is called hash. So to put it simply, say we have a transaction record that says Amy took 10 apples from Bob. Then when that transaction record goes through the hash function, it's gonna produce, in this example, B2L6. That string is made up, but the point is, it's gonna compress whatever information was contained in that transaction record and spit out this string. And one key point to know is that even if you change a little bit of the input, the hash function would produce a dramatically different output. So say in the right, you can see if someone changed Bob's name to Rob, the hash function would produce a completely different output that represents the original string. So the point here is that each hash would uniquely represent what the original data is. And that's really important to blockchain, as you can see in the next slide when we are trying to add a block. So to add a block, a user on the blockchain, or sometimes called a node, would need to calculate the hash of a block. So imagine what we just explained previously. It would compress whatever transaction record there was and convert it into a string. So after that's been calculated, the node would put whatever transaction record that it wants to add and put in a block with that previous hash. The reason why we do this is so that we can keep track of what the previous block is and what data it represents. So in the case that a previous block has been tampered with, then the block hash would not match up and the entire blockchain is invalidated. In some blockchains, so for example, in Bitcoins, this process requires a lot of computational power. To reward node from doing this, they are given the reward, and usually that reward is taking form of transaction fee. And these nodes are referred to as miners. So what a smart contract is really, it's just a type of transactions. So that's why it's different from a traditional program, because we can add a smart contract to a blockchain. And that's why we need a smart contract to use on the blockchain. So now that we mentioned the concept of smart contract, what really is a smart contract? So before we go into that, let's look at what a contract is. So a contract really is an agreement intended to be enforced by a trusted third party. So in this use case, user A and user B wants to make a trade. User A wants to give user B orange, and user B wants user A's apples. But the thing is, user A and user B, they do not trust each other. So in order to make a trade, they need to bring in the middleman C, where they both trust, and middleman C would take both A and B's items and make the trade for them. However, in most common scenarios, a middleman C would not usually be available. And even if the middleman C is available, there are usually a high fee associated with it, and usually a lot of wasted time would be, wasted to find such a middleman, and the process may take a long time, which is not something that we want. So how a smart contract, what a smart contract is, instead of having a middleman, is a digital agreement enforced by code. So user A and user B don't have to trust each other. What they really need to trust is the code. And having being code, it's efficient because it executes automatically when the conditions are met. And you don't have to risk that the middleman, or the code in this case, like run away with all your goods. So yeah, and in this here, you can see the robot says, when I receive apples from A and oranges from B, B would get the apples and A would get the oranges. So both users are happy and they don't have to find a middleman to solve this issue. So the reason why we want to use a smart contract is it's transparent because it's in code. All terms and conditions are extremely clear and everyone on the blockchain can see it and knows about it. It's efficient because once the conditions are met, say A has 10 apples and B have like 15 oranges, the contract is executed automatically. So there will be no waste of time. And yeah, and we are certain that the contract is fulfilled. It's also secure because, as Jensen mentioned before, once the contract is added to a blockchain, it's immutable. So no one party can go in, change their copy of the contract, and argues that, the contract actually said this. So yeah, that would not happen. And yeah, it will stay on the blockchain. Everyone has a record of it. It's really cost effective. And as I mentioned before, it eliminates the need for middlemen. So you don't need to go about finding one. You don't have to waste time finding it, and you don't have to pay a fee. Yeah. So that basically covers my section for smart contract. And now I will be handing this session over to Pratik, who will lead you through the demo and how to write actual smart contract.
Thanks, Owen. So hey guys, I'm Pratik and I'm the blockchain engineer at BlockTEST. I'm going to be covering the section about writing smart contracts, and first I will go over the tools that we might need in order to do that. And finally, I would go through writing a demo of a smart contract that would give us some idea how to start. So the tools that we might need to build a smart contract are given on the slide here. Remix is one of the most commonly used online IDEs, and it has an inbuilt Ethereum test environment with it. The best part about this is that it is accessible through a website, so you do not need to install or do any prior settings if you want to run your contract. Next, Truffle. Truffle is a JavaScript-based developer environment that has a testing framework and an asset pipeline built with it. This is especially useful if you want to do some testing, and we have certain components of the UI that interact with our smart contract. Finally, MetaMask. This is a simple browser plugin that is used to run dApps, so it can be used to simulate how a smart contract and a UI work and see that behavior on the browser. If you want any more details on any of these tools, you can visit the website that is listed on the slide. I will be going a little deeper into Remix and show you some of the basic functions that it can do in the subsequent slide. Okay, so let me open the browser. And as soon as we open remix.ethereum.org, we get a sample ballot contract. So this is in Solidity, hence the .sol extension. Solidity is the language which is used to write Ethereum smart contracts, but we don't have to worry about this. You might go through it if you're interested, but for our webinar now, I'm going to create a new contract, and I'm going to call this my first contract. Okay. First, when we are starting our contract, the first thing we have to define is the pragma, which is simply the version of the language that we have to do. For this instance, I'm going to define that as pragma solidity 0.4.25. So this says that I'm using Solidity version 0.4.25 for the smart contract. Now, I'm going to define a contract. A contract is the main structure in any contract, and I'm going to name it my first contract. Okay, so now that we have this done, this forms the basic structure of a contract. What we are going to be doing is I'm going to define a variable called data, which is going to store a string, and we are going to have two functions which will set some data to it, and we'll see how we are able to get the data. So first we have to define the variable that we need. So I'm going to name it data, and the data type is going to be string because it could have alphanumeric values. Now we have to have a setter which allows us to define the data. In order to do that, I'm going to write a function called setData, and this is going to take in the string that we want our data to have. So I'm going to define the attribute like this, and it is going to be string s. This function should be accessible to everyone publicly. And for that reason, the access specifier is going to be public, and that's it. Inside this function, all we have to do is we have to set the string we are getting to the data variable. Our setter is ready. Next, I'm just going to need a getter, which allows me to read the data variable. For doing that, I'm going to follow a similar procedure. I'm going to do function get data. And this is not going to need any attribute because our data variable is in the contract itself. This is also going to be public, and this could be a constant function. Now, constant function is nothing, not a big concept. The whole idea is the constant function does not do any change to the contract itself. And as this get data function is only going to read our data variable, we are not doing any change to our contract in this function. So I can set it as a constant. And finally, we do want it to return something. So I'm going to write it as returns. And finally, the data type of the returned object, which is going to be a string, as our data attribute, data variable is a string. So I'm going to just open up the curly braces, and that's it. Inside this, all I'm going to be doing is return data. Oh, sorry. Yep. So there we go. Once this is done, this is all we need to do. Our contract is ready. I'm going to have to compile it. If you look over here, this shows ballot, which was the previous contract, which was already there. But I want to run my first contract. So I'm going to compile this. I can just click on this button. And now we see my first contract is in green. And there are a few warnings, but I won't really worry about them right now. The contract here is also changed to my first contract. So everything is good on the compile tab. I'm going to go over to the run tab so that we could interact with this contract and run it to get the data variable as we want. Over here, let me go over a few of the options that we have. Under environment, we have a few options. The JavaScript VM is what we are going to be choosing for this webinar. It is just a Ethereum environment based on JavaScript. Injected Web3 could be used when we are using MetaMask or any other similar tools. And this is helpful for testing our dApps. And finally, Web3 provider is useful when we want to use our own server for the test environment and the Ethereum network settings. So I'm going to choose JavaScript VM as a setting. The account just has a list of 5 different addresses. So each address is just a string of 40 hexadecimal characters, and these addresses can be used to identify a user or a smart contract. In order to help us with the testing, each of these 5 addresses have 100 Ether already there. This is not a real Ether, and you cannot sell this Ether and get some money in exchange for it. This is just to help you to do your testing. Now I'm going to leave it at the first account at the moment. Gas limit is the highest gas limit that we are willing to pay for the smart contract execution. And the value here has weight, which is just a unit of ether. One weight is very small part of an ether, and you could look more into it if you want. The default setting has a value of 0, which just means that I want to pay 0 weight for each unit of gas that my contract uses. Now, the gas limit is very useful here, because as every contract is going to be running on the Ethereum nodes, it is very important that the calculations that it do have an upper limit, because when something is running on the nodes, they have some computation cost associated with those. And if we have an infinite loop in the contract, the node will just continue running that and be stuck there. So in order to get out of situations like that, it is very important to have a gas limit. So that's all I had about this section. Let's just go ahead and start with deploying the contract and using it. First, I'm going to have to deploy it. I can just do that by clicking this button here. So the recorded transactions is 1, and I see that my first contract has been deployed. I'm just going to pull this up so that we have a better look. And this shows that the contract is deployed and all the other details we might need with it. The transaction is mined and execution is succeeded. And the maximum gas limit is this, but the transaction cost and execution cost is whatever is mentioned here. So I'm going to open this contract under the deployed contract section and open this. As we expect, there are 2 methods here. One is set data and the other is get data. Let's try doing a get data call now. If I'm doing a get data call, I see that there was a call generated and this gave me a string, but there was no value to the string. This is how it should be, because we do not have an initial value for the data variable set so far. In order to get something, I'm going to have to set a value to this. So I'm going to be typing it over here. Let the value be ABC, and I'm going to click on transact. So this call went through, and if I look at the details, I see that the decoded input is indeed ABC, and this was the string S, which comes over here in the set data function, and S gets set to data, which in turn is saved in our contract. So I'm gonna click on the get data now, and I get the ABC, which basically just return the data that was saved in our smart contracts. Cool. We have this done, but what if we want some additional security in our program? Now anyone can change the value of data here without any problem. But I would want to have a contract where only the owner is able to change the value of data, but anyone could get the data value back. So to do that, we're going to have to change the code slightly. We are going to need an address variable. As I spoke before about this address variable, you might remember that it has a length of 40 characters in hexadecimal. So I'm going to save this date. I'm going to set this data variable with the name of owner, and I'm going to have to set a constructor. So constructor will be called the first time that my program, the smart contract, is executed. And this is when I will be getting the owner. So all it does is that when our contract is executed for the first time, we are going to come inside this constructor. And finally here, I'm going to set the owner variable as message.sender. Message.sender is just the sender of the message. Any call to the contract is basically a message. So message.sender helps us get the address of the sender, and this in turn is saved in the owner variable. And finally, when we are doing a set data, we have to make sure that it is the owner and no one else. So to do that, I'm going to have an assert statement over here saying assert message dot sender double equal to owner. So this line will make sure that the sender of a message to the set data function is indeed the same address as what the owner variable has. If not, it should not access the data variable and will not be able to change the data variable here. That's all. So let's see how this works. I'm going to go again to the compile and I'm going to click on start compile. So there are no errors. That is good. Once I'm on the run, I'm going to choose the third account address here, just to have a fresh account sending this contract over. And I'm going to click on deploy. Okay, let me clear these before that. So I'm clearing the logs. Now everything is clear. I click on deploy. We have a new contract deployed over here. And the 100 ether also reduced because the contract deployment did consume some gas. Now I'm going to do the same thing. I'm going to click on get data and there is nothing returned. But when I set some data to it over here, so the string could be ABC. When I click on transact, it goes through, everything is fine again. Get data now gives me ABC back. So this is expected because the same owner of the contract tried to set the data. What happens if we use another account? To test it out, I'm going to try the 5th account now, and I'm going to try to set the data to something else. So let's say we set it to BlockTEST, and I click on transact. I get an error message here saying that the opcode is invalid and the execution might have thrown and there is some issue with this. This is how it should be because the assert statement basically throws an error and it is not letting a different account set the data. Now when I click on get data, we see that it is just returning ABC and the data variable that we set here has not been changed at all. Now what happens when the owner does the same thing? I'm going to switch back to the 3rd account, which was the owner's account, and I'm going to send over BlockTEST again. This time the transaction went through, and let's see what we get when I click on get data. There we go. We have the final string value that we had set, and we are able to get it back because it was sent by the owner contract address. So we learned how to write a smart contract and some of the tools that we might need to do that. Thank you for listening. We would like to take any questions you have right now. Okay, let me just open up the chat and yeah. Okay, so one of the questions is, I see you're building this on Ethereum Remix. What would be the difference if we were to build this through a Neo IDE? Now, there are a lot of small differences between every blockchain platform. So when you're talking about Ethereum IDE, Neo IDE, I assume that you're talking about Neo Echo compiler, which is again online. So they have their small differences. The coding can be done in different languages, be it Java or C# or something else. And they support another format called .avm, which actually takes, which can be saved and put into the Neo blockchain to deploy it. So I think that would really be outside the scope of this webinar because it is a little more complex, and it'll be good if you could talk to me outside this. Feel free to send me a mail or something, and I would be happy to talk to you about that if you have any questions. So you can feel free to unmute yourself and ask any question, or even write it down in the chat. All right, we have another question. Any source for learning a Solidity, especially in developing a gambling smart contract? Okay. I would really suggest you to take a look at some of the Solidity tutorials. I mean, they have their official documentation where you could get to learn some of the basics of smart contracts, some data types that might be needed, and then you might want to go from there to a gambling smart contract. It should not be very difficult. It's just important that you know what are the data types that you might want to use and how to go about it.
Also, we are planning to make this webinar like a series. So this will be the first webinar in all our series. So maybe this is not the right time to talk about, going to specific about applying the smart contract to different fields. This is more like, a hello world of all smart contracts. But coming up, we will host more webinars, and maybe then you can find the techniques that might be helpful to craft your own smart contracts. So stay tuned.
Yeah, and going off of that, not only if you have questions, but if you guys have some suggestions right now as to what you want to hear us talk about next, what kinds of topics you would like to hear us cover, like, feel free to put that in the messages right now. We'd love to address these and tailor them towards what you're interested in learning about. So feel free to share that.
Yeah, also, like, don't be shy if you have any more questions. I mean, we do plan to have this for another, for like 1 hour. So if you have any question, you can just type them out now, and we will be very happy to answer them. So we've got a suggestion on maybe have a future session and specifically focusing the topic on gambling smart contracts. We do appreciate this suggestion, and we will definitely take into consideration and having another webinar specifically tailored toward maybe not just gambling, but area just similar to entertainment and where blockchain technology can be applicable to those.
All right, so since there's no more questions, I think we're going to go ahead and wrap up this first webinar. I hope you guys all enjoyed Smart Contracts 101. Do we actually have one more question?
Yeah. This is a nice talk. Can you introduce your company?
Oh. Okay. Yeah. So we're BlockTEST, and basically, you're putting me on the spot here to give us a pitch, but no, basically, we are just trying to sort out this crazy blockchain space. We know there's a lot of unique projects out there with some really interesting technology, and what we're doing is we're really trying to use data and objective metrics to identify the best technology in the blockchain space and elevate those projects so they can become better known. We have a test net that is platform agnostic. Right now, it supports Ethereum, Neo, and Hyperledger, and there's many more platforms to come. But basically, any developer can come and submit their project, their blockchain solution to our test net, and we'll be able to evaluate its performance on a bunch of different metrics. So yeah, basically just our mission is we make blockchain transparent and easy to understand. And we provide independent evaluation and fact-based due diligence on blockchain projects across variable protocols. And our mission is to empower people to adopt it with ease. So that's what we're trying to do here. And we have over 6,000 projects in our database right now with 3 teams in the US, China, and Australia. So yeah, that's us.
Yeah. Yeah, so after this webinar, we will also be sending out an email and send any additional info that we might give. All the links you see during the webinar will also be included in that email. So yeah, you don't have to, if you would like, you can watch it again and get those links. But we will also be sending this slides and any other resources that you might need alongside with that email. Yeah. So yeah, thank you for coming. This is the BlockTEST developer / engineer team, and yeah, we appreciate your time to join this webinar. Yeah.
Thank you guys. Thanks for
you.
coming. Yeah.